people to come in from the lobby as everyone shows up, but I don't want to hold everybody up to start the meeting. So I want to thank everybody who is here. This is the third official event of the PA Climate Network. It is our second webinar. We had previously had one on the Mid-Atlantic Clean Hydrogen Hub out of the Philadelphia area. And today we have individuals from both Wilson Engineering and Wallace and Montgomery to discuss guaranteed energy savings agreements. It's a guide for local governments. So I imagine you're all pretty familiar with me, but I'm Christopher Naif, Energy Program Specialist in the Energy Programs Office of the Department of Environmental Protection. And one of the programs that I run is the Shared Energy Manager Program, which is designed to try to assist local governments with identifying aspects of their climate action and energy transition plans and completing benchmarking, energy analysis, and feasibility studies to try to take some aspects of those plans and put them into practice. So Patrick Martin and Peter Oven are here from Wilson, and they're going to be talking with us today to provide a little bit of an overview as to what guaranteed energy savings agreements are, how that particular tool can be of use to local governments, and the kinds of things that you can achieve with them. And I also have Wayne Martin here from Wallace and Montgomery. So Wayne is a project manager, correct, Wayne? Yep, with Wallace Montgomery currently. Previously was the city engineer for the city of Harrisburg, and during his time with Harrisburg had completed a couple of guaranteed energy savings agreements for the city. He's going to be discussing some of the more in-depth specifics about the project that he completed to convert over all of the city streetlights and traffic signals in the city of Harrisburg to LEDs, and what went into that process, the cost savings, and everything involved. So I don't want to hold anything up anymore, and I will turn over to Peter and Patrick to start off.
Hi, everyone. I'm going to give a bit of an overview of what a GIZA is and provide some examples for you of some GIZA projects that have been done in the state. First of all, a few key terms that I want to outline. GIZA is short for Guaranteed Energy Savings Act, which was a law in Pennsylvania passed in 2004 with legislative updates in 2010 and 2016. These legislative updates were based on the experience in the initial phase of the GIZA implementation and were intended to kind of enhance its usefulness and applicability in getting good energy projects done. ESCO refers to an energy savings company. These are the entities which are pre-qualified and set up in a certain way to be able to bid on a GIZA project for an entity. ECM is energy conservation measure. This is also known, depending on your company, as an EEM or an FIM. Basically, it's a particular project such as lighting or water conservation that has specific equipment that will be installed and a specific energy savings or efficiency that will be gained by completing it. IGA is investment grade audit. That is a type of audit that is done by the ESCO after they have been brought on board with the government agency, and that is used to determine what the ECMs are that are on the table. And MNV refers to measurement and verification. That is a process following implementation where the energy savings are verified. So a GIZA is used for a few different reasons. One of the most important is that you're able to implement ECMs in a budget neutral format. This means that the savings of an energy project, either through reducing energy, improving efficiency, or reducing utility costs, goes into making the payments on the amount that the equipment cost in the first place for the construction. So it allows you to essentially have a good payback on an energy project, and it's a delivery mechanism that will help you to build that project. The second reason is that you can reduce your utility costs and by reducing your energy consumption. And this is a way to do it, either by switching fuels, installing more efficient equipment, or by changing certain processes, which we'll go into later. This structure can be used by a bunch of different government entities, including federal, state, local, tribal schools, and other public institutions. In this case, we're talking about Pennsylvania specific, which is Pennsylvania DGS uses this, as well as local governments in Pennsylvania are able to use the GIZA project delivery format. Some of the benefits of the GIZA, going into more detail, are that you'll have measurable energy savings, which provides increased sustainability of your facility operations. It does not impact your operating or capital budgets. And this is particularly important in terms of how the act was structured. The financing, and I'm not a financing expert, but the financing of the GIZA is not coming out of your capital budget, and it's not coming out of your operating budget. It's sort of a separate pool of financing that you're able to access and get to do this project. You can include your facility maintenance staff in the development of the project, so it's not just something where you'll allow the ESCO to come in and do whatever projects they find to be like a good project in their eyes. It's a collaborative process that allows you to get the project that works best for your facility. And you're able to address deferred maintenance as well and upgrade your facility systems. What this last point does is it allows you to combine short-term and long-term payback projects into a single project which has an acceptable payback. In the GIZA Act, it specifically identifies that 20 years is the maximum expected payback for a combined project. So anywhere from like a short payback to a 20-year payback is what you can expect with a well-designed GIZA project. So some examples of projects. And this first project is for the Pennsylvania State Police. It was done by DGS, and this is based on after DGS was one of the first to kind of implement the GIZA process once the act was passed. They got a lot of experience early on and were able to recommend and implement their own kind of improvements to the GIZA process to make it even more successful. So this was done in 2019 after the 2 legislative updates. This GIZA project was for a bunch of state police facilities all over the state that allowed them to do lighting retrofits, boiler efficiency, and water conservation. And it was overall a $5 million project, which had both savings in electricity and savings from water. And it's important to note that the savings was guaranteed at a certain amount, but the actual savings was 20% more than it was projected. And those additional savings come back to the owner, to DGS. So it was successful in that respect. Another project to highlight that DGS helped to provide was SCI Dallas, which is located near Wilkes-Barre. This was primarily a conversion of a coal boiler plant to a gas boiler plant. So it was a fuel switch essentially, and that was $2 million of the savings was in that fuel switching, or about $2 million. That was one of the biggest components of this project, but other ones that were interesting were electricity. They did a lighting project to convert to LED lights, and they also had some optimizations to their wastewater treatment plant on site. They had a process that generated quite a bit of sludge every year that they had to haul off site. With the improvements from the GIZA, they were able to reduce the amount of water in the sludge and reduce the hauling costs, as well as improve the operation of their wastewater treatment plant. And this one also had actual savings that exceeded the guaranteed savings by quite a bit. The city of Harrisburg did a street lighting project. Chris referred to that one already, and Wayne's going to go into a lot more detail on that one. But basically, they worked with an ESCO to identify streetlights that they wanted to replace. The ESCO did a lot of analysis of the different streetlight types and worked with the city to figure out which streetlights should be replaced with what different bulbs to get the best energy savings. The city did also get rebates, a lot of which were the city directly receiving those rebates and not necessarily the ESCO receiving those rebates. It was sort of a mix, but overall, it was a highly successful project that had a lot of electrical savings as well as greenhouse gas reductions. And it did provide a more modernized street lighting environment with wireless control and some other like nice to have benefits, as well as just energy savings. The last one I'll touch on is Chester County. They did actually a 4-phase Giza, and I'm just going to talk about phase 1 because that was one of the ones that had the most interesting like energy savings projects. And you're able to do, now that I mentioned this, you can do multiple phases of a Giza where you can kind of bundle projects and do them in stages so that it's easier to manage depending on the size of your like maintenance staff or administrative staff. This was a $6 million project with about $400,000 annual savings, which comes out to a 15-year simple payback. Some of the projects they did were water conservation, LED lighting, and overall they were able to save quite a bit of water per year. I'm going to pass it on to Patrick at this point to talk about some of the more nuanced details of how to implement the Giza.
Thanks, Peter. Do we skip one slide here?
Sorry, let me back up.
Yeah, I see.
I think we did.
Yeah, give me 1 second. I can pull it up.
I'm going to stop sharing. Sorry about that, guys.
You're good. All right. Is that up?
Yes.
Yes.
Good. All right. So yeah, as Peter said, I'm going to talk a little bit about the kind of Giza process and how you might consider the various steps in that process. And there's a lot of nuance in all of this, and I'm going to just kind of touch on each piece at a fairly high level. It is our intention to kind of at the end, after Wayne's able to give a lot more detail on the Harrisburg project, that we can hopefully have a little bit of discussion and get into a little bit more nuance if there's any pieces here that you guys would like to dig into a little bit more. So I guess to start off, here are the basic steps of a Giza process. And I won't read through each one, you can see on your screen, but what I'd like to highlight is there's 3 sort of key areas of this timeline, or key sections of the process. The first section is these 3 over to the left, steps 1, 2, 3. These are basically project conceptualization, initialization steps. This is where the owner of the project is determining, is a Giza the right tool for them to deliver their end goal project? What kind of measures or projects are they considering including in a Giza scope? How do they want to approach the Giza? And who might the team be that they want on board? Do they want to include, a third party technical assistance throughout the process to help guide them? Do they have that capability in-house? So this is really where they're setting up how they're going to approach the process. And this includes site surveying and development of an RFP for the ESCO themselves. So this is where you're going to define how you're going to move forward. In putting out the RFP to select an ESCO, that's where you start to move towards the second area here. And we'll talk about each of these steps in the coming slides a little bit more. But in the middle section, you've selected the ESCO and you are finalizing the project scope, doing detailed engineering, getting the financing for the project, and moving into actually constructing the measures and beginning to work towards energy savings. These last 2 steps in the process are after construction is complete and you've commissioned the equipment or the measures and are moving into what's considered the performance period. This is when you're accruing savings to actually make the debt service on the projects that you've constructed. And during that period is when it's important to do measurement and verification, as Peter alluded to earlier. to determine what the savings of the project actually are, and make sure that they are appropriate to cover the debt service payments and any ongoing costs associated with the installed equipment. So the first item that we'll talk about is the project scoping, site surveying. This is where you'll start once you've decided that a GISA is the tool that you'd like to use for project delivery. You'll want to include specifically, where you're actually planning to go with this. So it's important to make sure from the outset that you define what, as the owner, your goals of the GISA are. Are you looking to address some amount of deferred maintenance? Are you looking to specifically have high impact greenhouse gas emission reductions? And there could be a mix of those. There could be other priorities as well. But you'll want to make sure that you're defining from the outset what your end project needs to do, which will help guide all of the steps throughout. And so you'll want to consider what energy saving strategies you'll include. It can include lighting, like Peter had mentioned, some fuel switching. It can include renewable energies like solar PV installations. And once you have kind of at least a base core of these are the items that we want to consider, you'll package that into an RFP and solicit proposals back from ESCOs who are qualified to deliver those projects. And as part of the RFP selection, which I'll move into in the next page, you'll want to include a site survey as part of that. So there is, it's important while you are soliciting ESCOs for delivering these projects that you are maintaining control of the project scope and also maintaining obtaining apples to apples comparisons of the proposals that you will get back from the ESCOs. And so it's important in the RFP to include enough detail of what kind of a project you're looking for to make sure that you're able to have that happen. So you'll want your RFP to include items such as what are the acceptable utility rate escalations in a cash flow? What are the M&V measurement verification processes and options that you're anticipating to be allowable? And what is the term or how long of M&V are you anticipating including? What are you willing to consider a 20-year project payback, or are your project needs such that you would not want anything longer than a 10-year payback? So all of this should be really defined in the RFP before you select the ESCO. And so you'll want to make sure also that in an RFP, you are requesting back a technical proposal that allows you to really evaluate how the ESCO will approach a project for you, because you'll want to determine which ESCO best partners with you as the owner to achieve the goals that you set at the outset of your process. And so you'll want to, if possible, require as part of their technical submission at least a preliminary evaluation of core ECMs. They'll want to have looked at the sites that you're including in your project. You'll want to be able to evaluate their approach to ECM design, their approach to project structure and cash flow, their approach to project pricing and cost reasonableness. You don't have to make the basis of the selection on cost, but you do want to evaluate what their typical approach to pricing of apples to apples ECMs are. And so moving at the end of this process, of course, you'll put out the RFP, get proposals back, score them. The end result of this is to select an ESCO that you would be partnering with to deliver the project that you've conceived of at the outset. So once you have the ESCO on board, that's the point where you would have them complete an investment grade audit. This is where they'll go to all the sites that you have included in your project scope. They'll do a detailed review of all of the energy usage at those sites. and develop an analysis of all potential energy conservation measures that they identify through review of the site and the utility data and any other data that they are able to get through. And so the investment grade audit it'll be the core of how the project can be structured moving forward. So it's the basis for your energy savings. It's the basis for your cost savings. It's the basis for what the scope of each energy conservation measure will be. And it's important to make sure that that the IGA is done in a transparent way to where you as the owner can understand the nuts and bolts of what's actually going into the project. And so during the IGA is when they'll also do enough surveying and engineering to do concept level engineering on the identified energy conservation measures. So the output of the IGA is such that you'll be able to, as the name would imply, make an investment grade decision based on it. So it would include concept level engineering of the measures. Following the IGA is where the owner and the ESCO will collaborate and make sure that the final project scope meets all needs. And so this is where there'll be a little bit of shifting. Generally, the ESCO will propose, some set of energy conservation measures across the sites that are included in a EPC, and will that project the owner will review, maybe make some priority adjustments. Maybe this is not something that we want to include, but we really want to include this deferred maintenance item at this other site as well. This is where really the IGA will be able to provide the background needed to structure a project that meets the owner's needs in the end. And so once the project scope is finalized, costs are determined, and overall project cost is agreed upon, then this is when the team would solicit financing to actually be able to pay for the project construction. And so this can be either solicited through the ESCO, it can be solicited outside of the ESCO, just depends on what the owner's best route for financing is. And so following project financing, this is when the ESCO will deliver the project that was finalized after the IGA. And so during construction, the ESCO will typically over the period of 6 to 18 months, depending on project size, it can be a little bit longer. Usually it's not going to be much shorter than 6 months. You can deliver, or the ESCO will deliver the project scope, and energy savings will start to accrue throughout this period as well as the energy conservation measures are installed. And so after construction, this is when, as I mentioned before, this is the project performance period. So this is when energy savings are accruing and the owner is making debt service payments on the financing that was obtained to pay for the construction. And so this starts at project acceptance. This is when the ESCO will essentially turn over the project to the owner. Obviously be final approvals and commissioning of the equipment and verification that it's operating as intended, and delivering the savings that were anticipated and guaranteed under the IGA calculations. And so throughout the performance period, there is measurement and verification of those savings to make sure that they're appropriate to cover the debt service obligations of the owner. There are different approaches to measurement and verification. You can do it throughout the entire project term. If it's a 20-year project, you can do M&V every year for 20 years. The approach that DGS utilizes for their GISA program is to do a 3-year measurement period. So with the option to extend at the discretion of the agency. So if you have 3 years of M&V under their process, and everything looks copacetic, nothing is raising red flags, and it's anticipated that the project will continue to perform appropriately, then they discontinue the M&V, since there is an annual cost associated with it. So they view it as 3 years as sufficient to verify performance, and then they don't incur the cost for the remainder of the repayment period. And so there's a couple slides on lessons learned, and I'll just go through these real quickly. And the first one is on the process of the GISA. So this is what Peter alluded to a little bit in some of these, where DGS was able to kind of make some revisions in the 2016, 2017 time period based on lessons learned as to how they structured their process for GISA and state agencies. And so I'll just read through these a little bit. So the agency decides the project scope at least partially prior to ESCO selection. So this is essentially discussing that the agency needs to maintain control of the direction of the project rather than putting out an open, essentially, RFP for requesting that ESCOs come in and tell them what projects they may want to look at, the ESCOs, I mean. It's important that you get the project that meets the owner's requirements rather than the project that you may get from the particular selected ESCO that you may not get from a different ESCO. It's important to make sure that that's apples to apples. The smallest project is about $1 million. This is basically related to the ability to finance the project and also the ability for an ESCO to deliver it with the associated overhead. You might have a project smaller than this, but generally speaking, around $1 million is kind of where you would start considering that GISA might be an appropriate tool to deliver the project. A combination of smaller sites into one project is acceptable. So if you have distributed, 5, 10, 100 sites, depending on how you might want to phase the project and your overall goals, you can include a subset of those, you can include all of them. There's no problem with that in terms of aggregating sites into one GISA project. And this last one I think is very important, utilizing a third party for technical review throughout the process. So this is kind of across all the process steps that I identified in the beginning, from project inception through RFP, through construction, through measurement verification. It's important that if you do not have the expertise in-house to review the energy savings calculations, to review the project cash flows, to review the energy conservation measures that are included in the scope, either in the RFP or in the IGA itself, it would be important to consider using a third-party consultant to provide that expertise on the owner's behalf. Taking DGS as an example, again, they require that there's a consultant, a third-party consultant included in every project. And you can structure that also potentially into the GISA contract itself. You can have a provision for a third-party consultant to be brought in under the ESCO and have that included in the project costs. And then the last point I'll touch on is lessons learned, the people to include. The team that you have working on your GISA project is very important. You have to have the right people and make sure that they're all included to actually make sure that the project delivered meets the owner's intent. So you want to include maintenance folks at your site. They know the site, they know the deferred maintenance, they know the on-the-ground items that actually may be included and be important to consider when you're developing the project. You want to include, any financial people on your team. There's project cash flows and cost buildups that are included in the IGA or the actual energy savings contract itself. There's a lot of assumptions that go into those and a lot of particular points which are important to understand and negotiate appropriately. The funding agency during construction, it's very important to have somebody on site to make sure that the project construction matches the actual needs of the owner and the measures are installed as the owner needs in the end. And then this last bullet point, this may look a little bit different for smaller municipalities than it does for DGS. But there needs to be a key decision maker included in the team and to be aware of the project components that are going on. So if there is a dispute or an issue that the ESCO brings up during either construction or the audit or during measurement verification, there needs to be a decision maker internally who is aware of the program and the original goals and how the project has evolved over time, and make sure that that entity is able to settle any disputes. And so with that, I think I've gone over a little bit, but I'm going to hand it over to Wayne to discuss in more specifics the Harrisburg project.
Thank you,
Well,
Patrick.
thank
and
you.
Peter.
Yep.
Sorry.
Thank you. Can everyone hear me? Yep. Okay. So City of Harrisburg, 2011, you might recall if you're in the area, city first capital city to file for Chapter 9 bankruptcy protection. Because the county had backed a lot of those loans, the state was quick to step in, challenge that bankruptcy filing, and the city went into receivership. When the receiver took over, financial audits were completed and street lighting was identified as the city's largest non-personnel cost. I joined the city in 2019 as city engineer, and this was one of the first projects we worked on. So history of the streetlights in Harrisburg. This is a picture taken last week. Kidding. There's a lot of nuances regarding ownership of the poles. The city had 126 electricity accounts, PPL's utility provider, that streetlights showed up on in various bills. So you think 100, maybe 100 of them were traffic signals with streetlights connected. Some were just at the signalized intersection. Some had conduits running up and down the corridor. So those are the metered accounts. Then there were the unmetered accounts. Some were streetlights on PP&L poles. Some were city-owned streetlights on city-owned poles. Some were PP&L owned lights on PP&L owned poles. Some were PP&L owned lights on city poles. So you had a lot going on here. The city had a maintenance team that was dedicated. That was their sole job, to maintain streetlights. They were union employees, ASME employees, which is important consideration. And then there's a lot of infrastructure issues, right? So we had overhead feeds, underground feeds, especially in the downtown area. Pretty complicated situation. So first thing we had to do when the project to convert to LED was decided, and it was actually in the receiver. So we actually had a Commonwealth Court order, acknowledging the receiver's recovery plan for the city of Harrisburg, and basically a Commonwealth Court ordering us to convert to LED. So it wasn't just like something that the city decided to do on its own. It was more or less a directive from above. But we wanted to select the right procurement method. I had worked at the Department of General Services, had started the Giza. I was involved in their legal department doing some of the contracting prior to my time with the city. So when I came with the city, I knew about the Giza. We discussed the various procurement methods. I talked about that ASME union. There was a union filed a grievance, said that they wanted to replace all the lights themselves. They felt that they could do it. We had over 6,000 lights in the city and 5 people. We didn't one bucket truck. So, we pushed back on that, and that was quickly. There was still enough work for those union folks. With the infrastructure, the wires and everything going to those fixtures, that we kept them busy for a while. So Patrick talked about the consultant selection process. We had to develop a mechanism of how we're going to do it. 2 things I want to bring up, if it's not already obvious. One, it's a guaranteed energy savings, guaranteed. So that ESCO is going to guarantee those energy savings. And if those energy savings are not met, and assuming the municipality or county does everything, owner does everything on their end, that ESCO has to pony up, the difference in money. So that's a big deal, and really important to a city in financial distress that just can't make up that difference if it comes to that. And the other point I want to make is this is a design build environment, if that's not obvious. So you're going to contract, your local entity is going to contract with one company. They're going to do both the design and construction, the audit, the design, the construction, and then the measurement and verification. Now they may have subs involved and everything else, but it's not like a traditional bid build, design bid build situation. So when we did a consultant selection process, we did a two-phase process. So we did a request for interest first to find out who might be interested. And, I was looking at Patrick's sort of timeline and his graph, and that's exactly how you want to follow it, right? We collected all of our energy bills for a year, all 126 accounts. Thank God PPL has access to, historical records. We were able to, gather all that data, put that in a folder. Went out and took pictures of all the different streetlights that, we felt should be included in this project. And, you're talking the Cobra head style fixtures, the decorative poles, park lighting, lighting at fire, exterior lighting at fire stations, lighting under tunnels, like the wall packs, just a huge variety of different lights, different wattages, different configurations. So we just took pictures of everything we could think of. Any as-built records we might have, we put them all in folders and made them available to those interested in this. And so the second step we did interviews, and we shortlisted, did interviews, and then asked for technical and price proposals. The only price that we requested was a budget estimate and the actual cost for the investment grade audit. And that's something that, as you're going through this process, you'll have to decide on whether or not to pay for the investment grade audit. If you don't pay for it, it's going to be wrapped into the final, the final project cost. If you do pay for it, it's a lot easier to back out of if either you don't like the scope, you don't like the project, you don't like the ESCO, but the information you've paid for, and maybe you decide to do it with in-house staff or what have you. Understanding regulatory barriers. This was a big one. And this is the, Patrick mentioned the third-party evaluator. We brought one in particularly to deal with the utility company. Just understanding the regulatory barriers. The city had been purchasing back streetlights for some time, and after this project, there was actually a moratorium on buyback agreements for the purchase of municipal from this utility for the purchase of the streetlights. But there was a lot going on, and some of the streetlights in the city are still owned by, I think about 150 maybe, are still owned by the utility commission. And those are a lot of the downtown ones with underground, and it's just too costly to separate the utility feeds from those assets. You'd have to put in manholes or handholds or disconnects and things like that. So it just got real costly with the excavation, obviously. So just understanding, and the tariffs and all these different things. So that was I don't know that that'll be true of all of your GIZA, especially if you're dealing with windows and lighting and building type stuff, but definitely with the streetlights, it was a consideration. And then obviously we are under a high level of scrutiny with with the city being in receivership, and that was both from exterior, the receiver, the public. I mean, when the city went bankrupt, they owed, I think it was $50,000 per every man, woman, and child living in the city. They were in debt, and there was only, median income was like $30,000 per family, right? So there was a lot of scrutiny placed on this project. So the city needed a win, and we had to get it right. So the investment grade audit was done by 10, I think the efficiency network is what they're called. I think they're still around. They're DGS qualified ESCO. There were 6,127 fixtures audited, various street lights. This is what they came up with as far as the energy savings in their investment grade audit. And you'll see maybe in other presentations, other accounts of these numbers are going to be a little bit different. These are actual bills. This was September, of 14 and September of 2016. And the reason you have to get the same month is because you have to realize that the way they bill non-metered electric counts is the longer the days, the more you pay. So in the winter months, you pay more for your street lighting. And so you have to compare. So there you can see the monetary difference. The other thing to keep in mind is, that what was happening at this time was the third-party generation costs. You were able to bid those third-party generation costs, and the city actually put out the third-party at about the same time we started to bid out our energy, our generation, and the prices were going down. Which actually kind of hurts your return on investment in a way, because you wouldn't be paying as much for electricity. I know it seems kind of counterintuitive, but I'm saying a utility bill reduction of 60, 70, that's more like the energy savings reduction, whereas you can see the monetary savings is probably more in the 50, 55%. Going too fast. So, it's obviously it was important in this project to get the public's feedback. We were in a prime position, being able to purchase so many different lights. We got samples from all the major manufacturers, and we had three. We asked all the major manufacturers, if you want to be part of this project, we want your 250 watt equivalent fixture that, closest to you here, this guy, that's your halophane light. That's your 250 watt halophane light. So we want your LED equivalent of this light. We want 3 of them. We're going to put 2 of them out on the street, and we're going to put 1 in City Hall. We wired all these up so you could turn them on, look at them, and then this was Front Street in Harrisburg, and you could drive down the street and see all the different manufacturers' light. And this went on for about 3 months, and we asked for the public's feedback, and we got some ridicule from manufacturers saying, "I can't believe you're letting the public pick which light you're going to put up." And it was one part of the formula. It wasn't the only part, as I'll explain, but we thought it was important to get public feedback and input on the process. Okay, so going through the fixture selection. So not only did we have the ESCO, complete the investment grade audit, but obviously which manufacturer you go with, right? So part of the advantage of a Giza is you can get the equipment you want, right? But we did ask them to do a life cycle cost analysis of the different fixtures. And so you're looking up here at your different, wattage fixtures, and these are the Cobra head style. These aren't the decorative, but these are the quantities of the different types. So obviously we had 1853, 50, 55 watt equivalent. So we had most of those. But anyway, we went through the analysis and we asked them to rank, and Philips came out most energy efficient, but the most energy saves was the Cooper Eaton, and that was the one that we selected, had the best overall cost, life cycle cost over the 10-year period. 10-year was the warranty period. That's another advantage of going through this process, is we could negotiate the warranty, with the manufacturers, being a large purchaser. And, keep that in mind. We thought about, when I said about maybe the city could install the lights themselves, we ended up paying, I think, just over $200 a fixture for material under this contract, because we were buying such huge volumes. Not only were we buying huge volumes, but our ESCO was buying, enough fixtures to light, like City of Baltimore, I think, was under their contract. So they're buying 36,000 fixtures for them, 6,000 for us. And, the cost of buying in bulk obviously paid off. So the investment grade audit produced a GIS map of all the fixtures in the city. And we thought it was important to utilize this map during the, install of the fixtures. And so residents could look up on the map, where are we at, which lights were installed yesterday. So blue means that they've been converted, and the orange means that they had yet to be converted. So this is just a snapshot in history. The yellow were flags. That means there was some kind of infrastructure issue when the contractors went out to install the light didn't come on. So that's the ones where we deployed our city forces. We told them they'd have work to do. They went out and addressed whatever infrastructure issues might be causing that light to not come on. So we did deploy controls. So it's, right on top of your light fixture is this NEMA telecell. This provides, we have a command and control center. They can dim lights, trim the lights, things like that. Going back to Patrick's point about that third-party verifier, you know, a lot of questions came up during the interview process, during the selection process, and we had ESCOs trying to convince us that you can dim and trim lights, and that energy saved on these street lights, the energy saved would go back to the city. But that wasn't true. Okay, the utility said there's no way they can verify that you're dimming and trimming non-metered accounts, right? So there's no way they can give you those savings, and there is no savings recognized in the Public Utility Commission's, you know, rate structure. So whatever, you know, they may be relying on this huge savings for dimming and trimming that you can never receive. So it is important to know these nuances in these regulatory environment that you're dealing with in these projects. We prioritize economic development areas. Contractors generally followed our street cleaning schedule, you know, where the parked cars were removed from the street so that they can get in there. We had 7 crews. One crew was doing at least 70 fixtures a day. And then we had the 2 city crews dealing with the infrastructure issues, as I discussed. So this is what the control center looks like. So we can, you know, the green in this case, that's a base station in yellow, and the green are the ones that are connected to that base station. Don't want that to confuse you. This is, if you go on the individual thing, you can click on the different charts. This is the energy consumption graph, and you can see the days must have been getting longer because it's using more energy. But there's a lot of things you can utilize this software for: energy usage, event logs, dimming, trimming, things like that. So here is the outcome. I think I mentioned there was 126 utility accounts. Here it says 160. I think 160 was the total amount of utility accounts the city dealt with, and 126 are the ones where the street lights showed up. I should probably fix that in the slide. So unexpected benefits, you know, the fact that we went with a control system allowed us to commission the lights. There's a commissioning phase in any of these, you know, where you verify that the equipment is working according, you know, to the manufacturer's recommendations and everything like that. Basically, on a street light, you'd make sure that the light had been replaced. Well, that's a lot of lights, right? You had 7 crews doing 70 lights a day. That's more than one person driving around. And I did do some driving around to make sure, you know, things were installed. But having you know, once that control device is connected, I could log in and see that they were actually replaced, what the energy usage was, and things like that. So definitely there was some speed in that commissioning. Real-time response to utility disruption. So this is kind of interesting. We were finding, so a lot of these aerial feeds, right, are coming from the utility, and the utility would say, hey, everything, you know, your light should be fine. And we'd go out during the day and we'd put in a new light and everything's working fine. And then the resident would say, hey, that light didn't come on last night. I thought you were going to replace it or whatever. And we were finding that there was power drops on the aerial feeds to these lights due to the utility issue. So we were able to, you know, hone in on these issues, and it didn't happen during the day because there was less draw, I guess, on these, you know, especially on the end of the line sort of street lights. And we were able to communicate this and show the utility what was happening with the drops, you know, through that centralized control system. Obviously, improved service in the city of Harrisburg has a lot of areas where, you know, maybe English is a second language situation. Maybe they just don't trust the city government to report 311, you know, light outages. Maybe they like the lights out. I don't know, but we were able, you know, be able to see what's really going on in real time. Helps improve service in those areas. The city, we did do a data on crime rate, and the crime rate had decreased. I don't know if it's correlation or not, but or causation or correlation, but yeah, it is what it is. I think the general consensus that the, you know, streetlight project itself was good. With hindsight, you know, with your centralized control system, maybe if you're doing a heating or in building lighting system, you're going to use like a BAS system. Make sure if it's integrated with your IT, make sure your IT department is on that project team, as well as those, you know, those maintenance staff, like Patrick said. It's real critical that they have buy-in to, because they, you know, they're going to have like walls set up, and maybe that ESCO is going to want control of that BAS system to make sure that, you're not cranking the heat way up, cranking in the wintertime, cranking the air way up in the summer. That would somehow disrupt the anticipated savings. And so I think this was an important slide to end on. The lighting under the arch was one of those, sort of added perks that we did, as part of the project. It was not a energy savings, although we did convert, white Hall of Fame high pressure sodium lights to LED. But this was the cost of delay of our project. So every day we didn't install these lights, we didn't convert to LED, we were losing $1,600 a day. So that was a big deal. And then you take the crash modification factor for street lighting. So if the lights were not adequate on a corridor, they're below what AASHTO and the design guideline PennDOT recommends for lighting. You have a potential for crash. You have a 31% crash reduction by bringing those lights up to current standards. Crime reduction, I put a question mark. I think it did have an impact, especially on minor car theft, break into a car, steal a wallet type situation. And then obviously the lighting, pollution, environmental impacts that everyone's interested in. And with that, turn it back over to Chris.
All right. Thanks, Wayne. Thank you, Peter, Patrick, and Wayne. One other quick point that I wanted to make. This was one of the environmental benefits. So during my time in the city, which was I was there at the same time as Wayne, but came in later, one of the responsibilities that I took over was the renewal of the city's electric procurement contract. And so what I found around 2020 when I went to do the renewal for the electricity for the city was that one of the effects of the Giza project that Wayne had put in place several years earlier was that it reduced the total electricity use of Harrisburg, of all municipal power, by 39%. So that was a pretty significant reduction in electric use and also greenhouse gas emissions. So just wanted to note that and thank them again for coming here to present to us, and open it up to see if anybody has any questions. If you want to just use the little hand raise function to do that. Or you can just type questions in the chat too if anybody has any questions there. Okay, looks like Lisbeth, let me see if I can give you guys the ability to actually talk. Hold on here. Okay. You should be good now if you unmute yourself.
Okay, did that work?
Yes.
So this has been great, super, super helpful. The last thing you mentioned about when you were negotiating the contract with the utility.
Sure.
So that the overall reduction, did you say 39%?
Yes. So I was trying to, when I was working with the city had a broker through Train, and I was looking at, this was the first point in time that the timing lined up for the streetlight contracts as well as the municipal facilities, because they were staggered before, so that the renewals didn't come at the same point in time. And when I was looking at the total electric use for the city, and the numbers weren't matching up. And when I looked into it, I realized it was because of the savings that had been achieved from this project previously, as well as some other work that Wayne had done. There was another small Giza that was done as well. And so those efforts had reduced the total, not all energy, because not natural gas, but the total electric use of the city by 39%.
So my question related to that is, there's that whole demand charge thing for commercial accounts. Like, what's the total you're going to need at any point in time? And then that becomes a multiplier for a bunch of other costs. So that reduction, like, does it impact that demand cost? Like the overall, does it have like is it a multiplier of savings because you're only going to ever ask for this much at a time? So it'll save you on those bills. Do you know that?
I'm not sure about that. That's a little bit more specific than what the
Okay.
level that I got into with the broker at the
Okay.
time.
Well, I mean, I bet it impacted your contract
Yeah,
because of that.
it definitely does. And I think I do remember when we were negotiating those contracts, those initial contracts, and we were going through the Giza, we had to include language in there that we may reduce the total energy usage by a certain percentage. Like we could go down in usage because they are selling you electric and they want to sell you a certain amount, right? So maybe perhaps that answered you. There was some negotiation on that part. So that's a good point to bring up. Anyone who's considering an energy savings contract while they're negotiating those contracts should keep that in mind and let their
Yeah.
solicitor know. Yep.
Because that's anything that's multiplied by every kilowatt hour you ever use, that's a figure you want to reduce. So cool, very cool. Thank you.
Sure. I think Greg, did you have your hand up a moment ago? Greg Smith.
Sure, thanks.
Sure.
Yeah, this is an impressive project here and some really great energy savings. I was asking, like, I think Philly is doing a similar project right now in terms of like streetlight replacement. Have you received any feedback from residents sort of like on the quality of light, sort of just like how they feel about it? Like, is it too bright? I'd heard some like feedback from some folks in Philly that they're feeling like the new streetlights are a little too bright, the LED ones. And can you like adjust the way those lights sort of like look essentially to people? It's more of like an aesthetic thing versus like.
Yeah, here's in a nutshell, there's a color temperature. The city of Harrisburg used a 4,000 Kelvin. So the original LED streetlights back in the day used like a real high, like 5,000 Kelvin color temperature. These were set at 4,000, which was the industry standard at the time and still is the PennDOT recommended color temperature, which PennDOT is relying on. I think it's FHWA, which says cars going 55 miles an hour or more it might be safer to have a color temperature at around 4,000. 4,000 is essentially moonlight. A lot of municipalities, including I think Philadelphia, City of Lancaster, I know, they're looking at more like a 32 or 3,000 Kelvin color temperature, which is like more yellow, softer light. And that I think especially in residential areas, is a lot more sort of comfortable. It looks more in line with the high pressure sodium lighting that everyone's used to. And then as far as dimming, yeah, we did have the capability to dim through the control system. So, we could dim at certain hours. We could do whatever we wanted, really.
Okay. Look like Cassandra. And you should be able to unmute yourself.
Yeah, so my question is, I've seen a lot of replacement of boilers and other things like that, but what about things like windows? Is that something a Giza could do?
Yeah, so replacement of long and short would be yes, building envelope, like replacement of windows with higher efficiency windows, adding insulation, weatherization type items that are maybe not wholesale replacements, but still help energy efficiency. That all can definitely be under a Giza. It's important it brings up a good point, which is so windows generally are going to be something that's a longer payback item. The amount of energy that you're going to save through a window is going to be somewhat smaller compared to its capital cost to actually replace it. And so that gets to a point that I think Peter brought up where a Giza can bundle measures that have shorter paybacks and longer paybacks as long as the aggregate can actually pay back within the acceptable period. So with that as an example, something like Windows, maybe it has a 40-year payback. Maybe you pair that with something like solar PV. If in your case it has a 10-year payback, maybe you can get that aggregate to 20 if that's acceptable, if just as an example.
And it looks like Laura also had a question. You should be able to unmute yourself. Laura Lim. Let me see here. Okay. Well, if you want to email me, that's fine. If you weren't able to come off mute, and so if nobody else
Hi,
had
this
any.
is Laura.
Oh,
Can you hear me?
there we go. Yes. Sorry.
I apologize. On my screen, I have like 4 mics X'd out, and I was just clicking on all of them, trying to figure out which one was going to play with me. So my question is, it's been a really great briefing, so thanks for providing it, and the questions and answers are great. But it looks like it's a little bit too high level, so I just wanted to ask, we're a smaller municipality, and I have 1 municipal building, and I've just been asked to research about changing all the regular lights and fluorescent lights in our building to LED. I only have 5 traffic signals that we're responsible for. We're that small. So is the Giza mechanism or process something that would be applicable to 1 building with about 100 bulbs that needs to be converted to LED?
You have a blanket statement, which is probably not.
Okay.
Only because the scope of the project, it doesn't have enough volume to really warrant the entire process, is what it comes down to.
No, I felt the same way. That's great. We're on the same page. I appreciate it.
And part of that is also that a lighting project could be a single trade, basically an electrical contractor. And so you wouldn't need to, like with the Giza, it bypasses the Separations Act, which allows you to kind of bundle multiple types of like HVAC and electrical into one contractor that manages it. Whereas a lighting project, a lot of times you can work with an electrical contractor, or you can put it out to bid to electrical contractors in a really simple way and kind of get proposals that way and then line up funding.
Yeah, I do know that there are other projects out there for rebates for lighting, and I'm aware of that. That's great. The other thing too is like, I mean, with your level, do you have any engagement with Pico or any of the other power companies that are responsible for the distribution fees and how the distribution rates on the bills have escalated greatly when they're averaging between 5 to 8% of energy electricity loss along your own power lines? Like, is there ever an engagement? Like, I understand how electricity works, but for their SCADA system and how that electricity is traveling through the network, we are losing, or they're losing, 5 to 7% of that electricity. But it seems that our distribution fees are going up every month.
That I don't think is something that people typically negotiate. It would be more of an item for the PUC to do like a regulatory proceeding if that is potentially unfair for consumers.
All right, thanks.
Okay. Well, I again want to thank all of our engineers for coming and doing the presentation for us today. And this meeting, as I said, was recorded. I am working to get both this as well as the session on the Mid-Atlantic Hydrogen Hub posted on the Climate Network website. Hopefully that will be by sometime next week. So I just want to thank everybody for coming, and hopefully we'll see you at the next event.